from looking at the audience, I can see a lot of familiar faces. So if you're a system engineer, imagine 10 years ago when you had to handle a project. If you're not a system engineer, imagine you were handling a client 5-10 years ago. And every time that client needed something, deployment, for example, or a change in his code, there was an entire pipeline of people that needed to help him. So he had to talk to PM, he had to talk to a system engineer who handled deployments, he had to talk to a QA, he had to even validate the whole deployment before it was done. Considering this, today the situation is a lot better. Basically, you can do everything more easier. What my presentation is basically about is the fact that today we have the tools, we have the necessary tools in order to help the client and empower him. So why would you need a one-click deployment? Well, it's simple and it's for two perspectives. The first one is for the customer's needs. So basically, if you allow the customer to do his own deployment by just clicking a button somewhere in his interface or in ours, you first and foremost of all empower him. So you don't need to have a lot of people that cater to his every need. He just has the possibility to decide when he wants to deploy, and he can do it himself or somebody from his team. He doesn't need a system engineer, an architect, a project manager, or whoever from our team to do it. And the last part is that it has efficiency because it doesn't really involve a lot of effort to just click a button. It's extremely simple. In our case, it allows us to have a standardized solution, and I'm sure all of you heard Adobe Talk. That basically translates into the fact that having a solution that looks to a certain degree the same in all projects will result in faster delivery cycles and, most importantly, project familiarity. So for anybody who ever switched a project, you know that you have to allow yourself to ramp up and see what actually has changed from your previous project. Also, it's free for all. So basically, what you can do is allow everyone in your team or your customer's team to do a deployment. So, I don't know, whoever, picture a content writer. He can just click a button and deliver the new version. It doesn't matter. And the last part is exactly that. You don't need any technical skills to do it. You just base yourself on the fact that the entire process is catered in the background by somebody else. So for a live demo, unfortunately, AAM wasn't too happy with me. So because the presentation is only 20 minutes, by the time that the infrastructure actually spins up in AWS, AAM starts, and the load balancers try to authenticate it, it doesn't work. It's too long. So I tried all this morning to figure a way to shut it down a little bit, but it's not working. So in this sense, we have an empty AWS, which basically has nothing, no instances, no security groups. Oh, it has some, sorry. And no load balancers. Okay, so basically what we can do is spin up a Terraform infrastructure. It's our new proof of concept. It's actually 3 commands, but I shortened it down so people won't get bored. It just prompts you if you're sure you want to build it, and that's it. And we'll leave it in the background, and we can continue with our presentation. So, how is this achievable? Well, I again thought it from 2 perspectives, because it's not only us, it's also the client. So it's useless if you have a pipeline that only you can use or understand, and it's also inefficient for him if he still has to rely on old methods to deploy it. So the customer journey should be as simple as possible and involve as less effort as possible. So, in my opinion, the customer should have a portal where we provide implementation for a set of APIs that are connected to our deployment pipeline. For example, you can use a tool like Ansible Tower, which allows API connectivity to deploy and trigger certain jobs. And if he just clicks on a button, Ansible Tower then triggers a job that deploys infrastructure and code at the same time. Basically, this is pretty achievable if we start using some other solutions that we're not using today. We can adapt ours, but they're not necessarily thought about that. After that, he just needs to wait for the job, find it if it's successful or not. It should be successful, and that's it. The trickier part is in the backend, because the backend has a lot of work coming from us, which again should be standardized. So, first, you need the configuration logic. So you need to have all the logic to be able to deploy programmatically and modular on every type of cloud or on-premise solution. So for example, there's a project in Seed called Terraform, which at this point is able to deploy in AWS and in Azure. Tudor, is Azure ready? He's not here? No. Okay, so that's why he's not here. This is, let's say, the easier part. The trickier part is to figure out the scenarios needed for the client so he can actually have a one-click deployment. So you have to take into account all the things that he actually wants to do in that platform. Does he or she want to just deploy once a month, or I don't know, maybe once a day, once an hour? Does he have certain triggers, certain conditions, certain needs on these deployments? And after that, you have to generate the workflows in order to be able to deploy. This basically is a set of jobs which can be triggered in anything from Jenkins to Ansible Tower to probably even Puppet, that allow you to just deploy unassisted. The last part is the API implementation on his side, which will allow everybody to do it, and a lot of QA to make sure it actually works. So, in theory, it's doable. In practice, it's a lot more interesting because first and foremost, you have code logic. So, exactly like I said before, the code itself should be programmatic and should be agnostic to any environment and as much as possible reusable wherever you can. The second part is workflow analysis, which in my case, when I started doing it, it wasn't so easy. It's easy to the point where you provision your basic infrastructure and just provision a basic AAM. If you want to do something more complex, it starts to get more complex. So, main focus should be always on the customer and first and foremost, cater to his needs. And after all is done, also make sure you implement automated testing to make sure everything is working properly and you have proper health checks for every step so you don't have surprises. And also implement monitoring and reporting. So, in terms of tools, there's a wide variety. For example, you have configuration tools like Ansible, Chef, Puppet. You have infrastructure tools. The first three at top are proprietary for each cloud provider separately. So the first one is for Azure, the second one is CloudFormation for AWS, the third one is Cloud Manager from Google. And you also have a stack of newer tools that are, let's say, agnostic to every cloud environment, like Ansible, Tower, and Terraform. And your CI/CD tools, Jenkins, CTN, whatever else you can think about. The interesting part in this entire scenario is that it doesn't really matter. You can use whatever you want. You can customize it however you need. No tool is better than the other. And the fact that you want to use a specific tool doesn't necessarily assure your success. So, what I learned from all of this after close to a month of trying to standardize Terraform without actually knowing Terraform is that good automation makes your life easier and you don't have headaches. Sorry. Like I said, tools don't matter. After I finished the Ansible part, the Terraform part for AWS, I figured out that the same thing can be done in Ansible Tower, so I kind of wanted to do it also. So it's basically the same API, just called by a different solution. It all boils down to what you actually like. It has no added value. Processes for the client and for ourselves should be simple and non-technical, so everyone can actually use it. And always focus on customer UX. I have a lot of nightmares from deployments where you have to leave a 5-page instruction sheet just to deploy some basic Linux stuff. And it wasn't fun. So, also, let's see how our little experiment is going. So, we had an empty solution. Now we have 3 machines provisioned at 236. Okay. And we have a load balancer. Actually, these are earlier. Provision at the same time. And you even have SSH access to those machines. The only thing missing is actually AAM, but it's missing because it needs about 25 minutes to spin up, and I couldn't get it to spin up faster if you include it in the stack. So for this particular presentation, it's not really possible, but if anyone is interested, I can share the code and access. Okay, so I took an IP. It's a new machine. Okay. So let's say calling Google. So we have internet access. It's not pingable because AWS by default usually stops SNMP. So this was basically my experiment trying to do a one-click deployment from 0 to an actual basic AM vanilla solution. My hope is that at least the Terraform part will be used in the future in AWS and Azure, so we can spin up client delivery, at least in terms of POCs, because it's a lot nicer when you tell a client, okay, you can have a vanilla POC in 2 days in terms of infrastructure, or 1 day or 2 hours, instead of, I don't know, a week. Okay, thank you very much, and if you have questions, feel free to ask.